This is a modular educational tool designed to assist visually impaired children in learning Braille. Braille letters are represented on individual building blocks, allowing visually impaired children to place them on a detection board to understand the pronunciation of each letter. It can also be used for spelling challenges, helping children grasp the pronunciation of words. R. Please try it again. R. E. Re. Well done. With its modular design, children can learn the composition of word beginnings and endings, and add or remove modules as needed to learn longer words. In this simple demonstration, users are tasked with spelling out the word redo. In the publishing module, which is the second one, two RFID readers read the data and store it in either Temp 1 or Temp 2, respectively. We then proceed to a conditional statement to differentiate which character has been read by comparing it to a predefined value. Subsequently, we publish an event corresponding to the character read. For example, if we read 43, which corresponds to the character, we will publish an event called ISD. On the subscribing side, which is the first module, the mechanisms are almost identical. The key difference is that after confirming the character, it will send data to the DF player to play the pronunciation accordingly. Additionally, it will subscribe to the events published by Module 2 and call the corresponding functions. For example, if the characters on Module 1 are R and E, and it receives the event ISDO, it will play track 9, which is redo. Well done! Originally, we encountered issues with the two Photon 2 devices communicating with each other. We realized that both devices should be under the same account. After several trials and consulting Particle's documentation, we discovered that the publish and subscribe functions are designed to trigger other functions and do not directly exchange data. As a result, we revised our code to enable communication between the two devices through events and functions. After figuring out the communication mechanisms between devices, we reorganized our prototyping blueprint, which visually represents the stages and actions of an interactive learning experience involving special bricks and pads. The using process is divided into three main stages: preparation, learning, review, and the flowchart introduces physical evidence, user actions, on-stage contact actions, and backstage contact actions for each stage. Throughout the learning process, the user is tasked with various challenges like spelling words with the bricks and placing them on the right pads, and they receive immediate feedback based on their actions. In our prototyping, we focus on the learning stage. The primary tasks involve identifying bricking and placing the bricks on designated pads. Various audio instructions guide the user. The system checks the placement of bricks using RFIDs and provides feedback through a speaker. If the user places the bricks correctly, they hear a "well done" message. If not, they are prompted to please try again.